Hi, I'm Paul. This is LeetCode sent me their challenge of the week, and it is string to integer in parentheses a to I. If there are any C programmers watching, they'll recognize A to I. So it's kind of a throwaway problem, but I mean, it's still medium level of difficulty. So, there are some ways to go wrong. All right. I'll implement the my a2I function, which takes a string as input, converts a string to a 32-bit signed integer. Here's the algorithm. We'll talk about the algorithm kind of in line with the implementation. There's a lot of examples here. 42, 42 of course converts to 42. Negative 0.42. You gotta, okay, whoa. Is that, no, there were no leading spaces. We ignore leading white space. We do not ignore negative signs. We do ignore leading zeros. So the output for this is negative 42. For this, we're going to get 1337. We just take everything, all the digits that we can up until the first non-digit. This one, output is 0. Because that negative sign is just not where it's supposed to be. So this one, output 0, because we don't have any digits before we get to the first non-digit. So the string is going to consist of letters, digits, spaces, plus, minus, and a dot. Now a dot is just going to be ignored as a non-digit in this case because we're looking for integers. Now this part here is interesting. Can I highlight that? Oh, there we go. And that is that the length of the string can be up to 200. So that's a very, very big number. All right, so let's keep that in mind. Now, we implement this. Let's see. Here's the algorithm. Remove leading white space. That's this. We can just do a trim. Now, it does say leading white space. It doesn't say to remove trailing white space, but if there is trailing white space, it's just going to be ignored anyway as non-digit characters. So a trim here is fine. We have a length of the string, and before we start indexing into the string, because the constraints said that the string can be length 0 to 200. So if the length is 0, let's just go ahead and return 0, and then we don't have to do any work. Other than that, we'll set the index I that we'll use to go through to index into the string. We're going to set the sign to 1. Sign meaning is it negative or positive, and look at the first character. Is it a sign character? So if it's a plus or if it's a minus, then we're going to set the sign accordingly. If it's a plus, set it to 1. Well, it's already 1, but for a plus sign, the sign is 1. For a negative sign, it's -1. And that'll make it easy to later to switch the sign of the number if we need to just multiply it times the sign variable. Increment I, so we can get the next character. All right. Let's see. Conversion. Read the integer by skipping leading zeros until a non-digit character is encountered or the end of the string is reached. All right. So we just have to deal with integers, right? As soon as we get to a non-digit, we stop. Or if we get to the end of the string, we stop. So here's the loop. This is for the end of this. This is testing for the end of the string right here. This is getting the next character. And this is checking to see if the next character is a digit. If it's not a digit, we're going to break out of this loop. All right. We're not doing anything specifically for leading zeros because they're handled by this computation. So result is set to 0, and as long as we have leading zeros, what we're going to have is 0 equals 0 times 10, which is 0, plus a 0 character minus a 0 character, which is 0. So it's still 0. As long as we have leading zeros, its result is going to stay at 0. It's only when we start getting non-zero digits that we start using the multiplication by 10 to shift digits to the left and add the new digit. All right. Once, well, here's the thing. 200, we can declare a long variable here, but even a long variable is not going to hold a 200-digit number. So, to avoid doing any more work than we need to, you could do this, with a string builder or something and just build up, a gigantic string or use a big integer. But what we're going to do is every time we do a computation on result, we are going to check and see if it is greater than the integer max value or less than the integer min value. And if it is, then, well, as it says here, sorry, I don't think I read that part of the algorithm. Rounding, if the integer is out of range of a 32-bit signed integer, then round the integer to remain in the range. Specifically, integers less than integer min value should be rounded to integer min value. Integers greater than integer max value should be rounded to integer max value. So we're just going to do that every time. And in that case, because integer max value only has, and integer min value only have, let's see, 10 digits, we can maybe save ourselves processing 190 extra digits just to find out that, something that we already knew, which is that the result is too big or it's too small. So every time we do a computation, multiply times the sign, see if it's too big, see if it's too small, and return the number accordingly. If that's not the case, then increment the index, go on to the next character. All right, when we're done with that, we take result times sign, meaning, we're just processing digits here. All we did with the negative sign, if there was a negative sign, was set sign to -1. So at the end, result, it's always going to be positive, but in the case of a negative number, we multiply times the sign, it goes negative. Result is a long, we truncate it to an int. All right. Here we go. Accepted. Submit. Okay, that passes. Okay, that's good. Yeah, I wanted to get a good time on that because I think that these two lines here, 29 and 30, are, potentially real time savers. Processing 10 digits instead of 200 digits. So, anything else? No, that's it. That's the LeetCode challenge of the week. Go ahead and subscribe. You'll get access to more stuff, and you'll get notified whenever we put up new content. So, see you next time.